All right, in the next section in 2.4, we're going to talk about algebraic reasoning. And in this section, this is really getting us ready for proofs, which is coming up, which is essentially kind of proving along the way what our steps are. So we're going to start that today. And the first thing that we need to remember are properties of equality. So I know that you've seen these before, but it's important in proofs that we have the justification we need. And it's just too hard to remember what everything's called, so we need to write them down. So the first property of equality is called the addition property of equality. And it just says if A is equal to B, then I can take and add C to both sides, which we already know. We've done lots of equation solving in our life that we know I can add something to both sides, and that's legal. It's called properties of equality. The same goes with subtraction. If, again, A is equal to B, so I'm solving an equation, any kind of equation, and I take and I subtract something from both sides, as long as I do it to both sides, then I still have equality. So we've done that a lot too. Of course, there's multiplication. So the same situation, sometimes I need to multiply both sides by something, and that's why they call it C. So I can take any equation and multiply both sides as long as it's the same number. And the same goes, of course, with division. Sometimes I need to solve something and I'll divide both sides by the same thing. So I'm dividing both by C. The next one is substitution. We've done a lot of this before. It says if I have an equation, so if A equals B, then A can be substituted for B. Since these are equal to each other, I can say A is the same as B, and I can say B is the same as A, which kind of seems like a silly thing, but we substitute a lot. So a lot of the substitution we've seen in the past is if they've said if if there's 2x plus 3 and x is equal to 4, what do you get? And we substitute in. So we've done a lot of that before. The other one that should be reviewed for us is called the distributive property, and we've distributed, of course, lots of times. If I have a quantity or a difference, like B plus C or B minus C, I guess it should say the same thing, that I can take A and distribute that in. That's legal for me to do, because sometimes we have to do some solving, right? And it gets a little messy when this stuff is trapped in here. So it's just saying that I can take A and multiply it to both B and C, and then I can go on from there and do whatever I need. The next one is called the reflexive property, and the reflexive property just states that A is equal to A. Seems kind of like a silly thing, but again, for our proofs, we're going to need it in some of our justification steps. The next one is the symmetric property, and it says that, again, if I have an equation, so if A equals B, then B also equals A. It's just flipping them. It has symmetry, right? The symmetric property. And then the last property today is called the transitive property, and it says that if A is B and B is C, then A has to be equal to C. And we just looked at one like that just the other day. So we've kind of been working on that transitive idea for a little bit. Now the last thing I'm going to show you is an example of what we're looking at. So they want us to solve an equation, which we're really good at. We've done lots of these, and justify each step along the way. So for instance, here is the equation. It is 6x minus 11 equals negative 35. And this first step, the justification, is that it's given. They gave that to me. I haven't even done anything yet. So along each line, I'm going to have a justification. Okay. The next step, well, to solve this, I know I'd add 11 to both sides to solve. And again, that's the addition property of equality. Notice I abbreviated it because I didn't feel like writing it all out. And then when I rewrite that, like rewrite what I have left after these 11s go, then that's really just simplified. Like I took that and I simplified that. Sometimes they call that substitution as well. Then next I'm going to divide. So I divide both sides, which is the division property of equality. Again, which is legal as long as I do both sides. And then really, I guess I simplified again, didn't I? When I divided both by 6 and I got x is equal to -4. So it's what we've already done. We've done lots of equation solving. This time though with proofs, and sometimes they call them two-column proofs, is that you have to have your work on one side and you have to have the justification on the other side. And every time you do something, you have to have a reason for it.